Greetings to you. Welcome to Physics with Ben. Don't forget to subscribe to my channel and click the notification button and also share this video to those that need it. In today's video, I want us to look at refraction of light through biconvex lens. We will be concentrating on this particular guy. In our previous video, we looked at reflection of light at plane mirror surfaces, reflection of light at curved mirror surfaces, laws of reflection. We looked at the calculations. We also looked at refraction of light through rectangular glass block. We looked at refraction of light through triangular glass prism. Click in the description box below and you will see all those videos. Without wasting much time, let us go straight to the point. Refraction of light through biconvex lens. Yes, people call it convex lens, but I prefer calling it biconvex lens. There are majorly two types of lens in physics. We have the biconcave and then the biconvex. Watch me. The biconcave, biconvex. The biconcave lens looks like this. It is thin at the center and thick at the edge. It is also called the divergent lens. Reason being that if we draw this as our principal axis, and here as the center of curvature of the lens, this is our line of symmetry. If, let's suppose the sun is propagating its rays. So if the rays of light passes through this guy, after refraction at the center of curvature, the rays of light will spread out. The rays of light will spread out from here, but then they will still come back. If you trace them down here, the rays of light, they will form a visual image on this side. This point is called the focal point, F of the mirror. So they will converge at this point. This is what happened. They will hit the surface and then spread out. For this reason, this guy, the biconcave. Look at it here. Thick at the edge and thin at the center. It sprays light after refraction at the center of curvature. However, we are not going to to concentrate on this guy in this video, we are going to lay much emphasis on the biconvex lens. This is called biconcave. This is biconcave lens. So let's look at the business of the day. The biconvex lens is thick at the center, and thin at the edge. This guy is also called the converging lens, meaning if we draw this as principal axis, let's position our sun here again with the rays. So this line is called the principal axis, and let's draw our line of symmetry here, which is the center of curvature of the mirror. So if the rays of light incidence on this surface, the rays of light incidence here, the parallel rays of light incidence on the surface, the rays will tend to converge at a point. That point of convergence, they will converge at this point. That point of convergence is called the focal point of the lens. The focal point of the biconvex lens. Please, I don't feel comfortable when they call this guy convex lens. It is called biconvex, not convex lens. This guy, the exams that are set on this guy in a particular year are so much. IGCSE, if you go through all their questions, you will see this guy there. If you go through WAEC and NECO, if you want to set any question on lenses, it is this particular guy. So I promise to make a video on the experiments concerning this guy. Why the theory of the video is very, very important, which is what you are watching right now. So please pay maximum attention. So this guy, because of this behavior, it is called the converging lens, because the rays of light, after refraction at the center of curvature, they converge at this point. This guy also behaves like the concave mirror. The behavior of the biconvex lens and the concave mirror, which I showed you in the other video, which is also used for cooking, is the same. The biconcave mirror is also called the converging mirror. The biconvex lens is also called the converging lens. Both of these two guys can be used to cook your food. If you put this guy under the sun and you position your hand at this point, you experience a strong sensation of pain. This guy too can be used to burn a paper. This guy too can be used to cook. So let's move on. The next line of action in this video is the geometry of this guy. Just like we did in the other video where I gave you the rules governing ray diagrams concerning the concave mirror, we also have the rules governing the ray diagrams concerning the biconvex lens. The rules are just three. I will state them pictorially. So we write rules for drawing ray diagrams. Okay, let me clean up so I'll have enough space. Rules for drawing ray diagrams. For what? By convex. Rules for drawing ray diagrams for what? By convex lens. There are two rules. Rule number one. This is my principal axis, right? And this is my convex lens. My center of curvature. A ray of light passing parallel to the principal axis. After refraction, for this guy, because the guy is biconvex, it has two faces. From here to here is called F, and from here to here is 2F. If the ray of light is coming from this angle, which is what I want to show you right now, if we choose this side, to be where the ray of light will come, everything on this side becomes F prime and 2F prime. So we write here, mind you, the distance from here to here must be the same as the distance from here to here. So we write here as what? Our F prime, and here as our 2F prime. The distance from here to here must be the same as from here to here. So if we choose that the ray of light should come from this end, then everything from this side becomes our what? Our 2F prime and what? Our F prime. For the sake of convenience, let's choose the ray of light to come from this end. So let's continue. Rule number one. A ray of light. I can position a ray of light. Let me just not position it. So this is a ray of light. A ray of light passing parallel to the principal axis. After refraction at the center of curvature, it must pass through the focal point. If it is coming from this end, it must pass through this place. That is rule number one. Rule number two. This is my convex lens again. And here I choose to be my F, and here my 2F. And here my F prime, my 2F prime. And here my C. A ray of light. Let me extend this lens. Good. A ray of light passing through the focal point. A ray of light passing through the focal point after refraction at the center of curvature C, it must pass parallel to the principal axis. Rule number two. Rule number three. Good. This is my 2F, my F, and then my F prime, my 2f prime. And then this is my C, the center of curvature. A ray of light passing through the center of curvature will refract through the same axis undeviated. A ray of light passing through the center of curvature will refract back in the same line undeviated. So, the next thing is the geometry of the whole system. So, as we did in the concave mirror, here too is the same thing. The position of the object, we could decide to place an object at 2f, at f, or between 2f and f, between f and c, and then that will determine the rules that we are going to combine to draw that particular ray diagram. Trust me. So right now, I want you to know, before we proceed, just know that from here, since from here to here must be the same as from here to here, it means that from the distance from here to this point is simply what? Your r, your radius of curvature. Don't forget what we did in concave mirror, where I drew something like this. That here is a line of symmetry, and here is a P, here is your F, and here is your C. In that video, I told you that the distance from here to this point must be the same as from here to here. So I said that from here to the pole to F is the small letter f. Good. And then from here to C is what? Your r. So we are going to do the same thing here. The same thing from F to C is simply the focal length of the lens. From F to C is simply the focal length of the lens. And from C to 2F is the radius of curvature of the lens. So let us draw one ray diagram, and then you want to use that as a template to draw other ray diagrams concerning biconvex lens. Are we good to go? Yes, we are good to go. Don't forget, I told you that the nature of the ray diagram is dependent, the choice of the rules we are going to use is dependent on the position of the object. In this case, the object is simply the light you are seeing here. But in diagram, we represent it as objects. Take notes. So how do you draw your ray diagram correctly? First things first, pick up your ruler. I'm using from 0 to 60. Draw a straight line. I choose 0 to 60. Locate the center of the line. 0 to 60 is what I want to use. And then extend this line. Extend the line. You may choose 0 to 15 and then extend the line to what? 30. So I choose 0, or you can choose 0 to 15, 0 to 10, and extend the line to what? To 15 or 30. So I choose 0 to 60. Please, this is a standard you must follow if you want to get the correct ray diagram for a lens or a mirror. So, locate the center of the line. I want to use 0 to 60. So, the center of the line here is what? Is 30. And that is actually where the line of symmetry of my lens will pass through. Now, the next thing you have to do for me is make sure that the distance from here to here is the same as from here to here. So we want to draw a lens of this height, a length of, we want to draw a length 20 cm high. Yes, a length of 20 cm high. And this is it. So from here to here is 10, and from here to here is 10. Good. That is supposed to be the line of symmetry. So the next thing is draw two curves at both ends. Good. So extend this line. This is actually the line of symmetry. And this is your C. This line is your C. The center of curvature. Your C. Good. The next thing I told you that, mind you, from here to here is 60. So from here to here is 30. From here to here is 30. Now, let's split from here to here into 2 and from here to here into 2. So from here to here, 15. 15 is the center of this line. So this is 0 to 30, and this is where our 15 is. And so, again, from 30 to 60, here again, this is where, at 15 cm mark, this is where the center is. So, good. So from here to here is 15. 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 From here to here is what? Good. The next thing we are going to do is to position. Now, we want to choose our light to come from this angle. Good. Our lights will come from this angle. In experiment, this is what you should expect. You see this light? It will come from this angle. So we are going to represent this light with a straight line. Arrow up. But before we do that, let's level this. This is from here to here is our F. From here to here. Because here to here is F, here to here is F. You need 2F to get what? 1 is your, so here is your 2F. And from this point to this point is your R, the radius of curvature. So here is your F prime, and here is your what? 2F prime. We can even say that here to here, to this point, is your R prime. Now from here we can derive our first length equation. Well, our R is equal to what? 2F. Our R is equal to what? 2F. Don't forget, from here, from F to C, is the focal length of the lens. From F to C, here is the focal point. If the rays are incident from this angle, they will converge at this point. If the rays are coming from this end, they must converge at this point. So, let us choose where our object will be. Our object, let's place our object at 2F. Our object height, we are choosing 5 cm. 5 cm is our object height. Good. Our object height is what? Object height is 5 cm. Our object height is 5 cm. This object is simply the ray box, the light that is coming out of here. That is the ray box. Good. So, rule number 1. Don't put it like this, not like this. make sure it is perfectly what aligned. So rule number 1, a ray of light passing parallel, a ray of light passing parallel to the principal axis. As you can see, you must draw the arrow. After refraction at the center of curvature, where must the ray pass? The ray must pass here. And so you position your ruler this way. After refraction, the ray must pass through here. Good. The ray must pass through F. You can't just use one rule. You must use 2 rules. So let's try. Rule number 2. A ray of light passing here, passing through C. A ray of light passing through the center of curvature. After refraction, it will return there undeviated. A ray of light passing through C, after refraction, it will return back here. Yes, our diagram is almost accurate, because if you place an object at 2F, the image must be formed at 2F prime. And we were very close, just 1.0 cm close to F prime. Because if you do it in your book, it will be more accurate. You can equally use the other words, rule. Let's try rule number 3. A ray of light passing through F. Passing through F. Yes. Rule number 3 can also go. A ray of light passing through F. So where this object is placed right now allows us to use all the 3 rules. There are sometimes you have to use just 2 rules based on the position of the object. And guess what? In fact, rule number 3 gave us exactly the result we were looking for. A ray of light passing through. Wow, perfect. So this particular rule, look at where it is. We apply rule number 1. A ray of light moving here must pass through here. A ray of light passing here remains undeviated. A ray of light passing here, passing through F, focal point, after refraction must pass parallel to the principal axis. So rule number 1 and 3 gave us the perfect diagram we're looking for. So let me just clean the second rule. Let me just clean this rule here. And then we are good to go. So that I don't confuse you. So as I said, when this is 2F prime, this is where the image is. When an object is placed at 2F, the image must be formed at 2F prime. And that is exactly what you see here. However, the image will be what? Upside down. The image must be what? Upside down. There's a little change here. The image height is slightly high. Reason being that the geometry is not perfectly drawn. The next thing is the characteristics of the image formed. Now take notes. From here, from where the object is placed to the center of C is called the object distance, U. It's called the object distance, U. And from where is the image? This is where the image is formed, where this line intersects. From where the image is formed, it is called what? I. The image is high. So From where the image is formed to the center of curvature from this other side is called what? V, image distance. From here, from where this object is to the center of curvature is called object distance U. And from where the center of the center of curvature is the principal, the line of symmetry of the lens to where the image is formed here is called the image distance. And from here to here is called the image height. In this case, our image height is slightly 6 cm above. Here was 5 cm above. So with this, we can generate all our our lens equation. Equation number 1, we have our R is equal to what? 2F. R is equal to what? 2F. From here to here is same as from here to here. So you need 2F to get what? 1R. Number 2. 1 over F, equation number 2. 1 over this F is equal to what? 1 over U plus 1 over V. And then there's something called the power of the lens. The power of the lens P is equal to what? 1 all over this F. The last one is magnification of the lens. It's given as what? V all over U, or image height divided by what? Object what? Height. This is the the lens geometry I was talking about. Very, very simple. You can replicate this idea and draw all the lens geometry or diagram that you want to draw. They may ask you, an object is placed at F. What is the property of the image form? Now, before I complete this video, let's write the characteristics of the image form here. Number 1, in an accurate geometry, this is what you state about this particular position of the object. Number 1, characteristics of what? Image formed. 1, image is what? Same size as what? The what? Object. Number 2, if you put your screen here, that is where the image will be captured. So the image is what? Real. Image is what? Real. Number 3, image is what? Inverted. Arrow down. It was arrow up, but arrow down here. All lenses will give you arrow down images. Number 4, the image is formed. Image is what? At 2F prime. This is what the examiners will require of you anytime a question is asked on this particular topic. Replicate this by challenging yourself in placing the object between 2F. That is your assignment. Try to place the object between 2F, follow the procedure at F, between F and C, and let me see the properties of the image formed. Thank you for subscribing to Physics with Ben and for watching this video. Don't forget to share this video to those that need it. Bye bye and God bless you.